Hello, everyone. We have 1 minute to go just to test technology. Can somebody confirm that you can hear me and you can see my computer?
Yeah, we can hear you.
Thank you so much, Elizabeth. I appreciate. All right. Last time we talked about the chart features, so I'm not sure it is available now. So what we do? Okay, so I think we have chart area. Yeah. All right, so this lecture is being recorded. I'm going to adjust my computer so that I can see the chart. Are there any questions, anything?
Yes, I have a super quick question.
Please.
Let me just pull up the right screen here.
Okay.
For the homework problem set, I was a little confused as to which problems were assigned from last week. So here it says on the document, selected problems, it's 2, and then it's got some questions, chapter 3, and then some questions. And then it says chapters 4, 5, 6, 7, 8, 9. So I'm wondering if you meant all of the questions in those chapters?
Correct. So all the questions from those chapters, correct. So just to make sure everyone on the same page, so I'm going to open up the question set so that people know what we are talking about. So on D2L, if you go to content, and then we have class notes. Class notes, lecture recordings. Where did you find those class notes? Is it here? Let me try. No, that is not.
No, I think it's under the lecture with recordings, the bottom one.
Lecture recordings. Thank you so much. Okay, thank you. It is under lecture recordings, selected problems. So you would do, for example, chapter 2, suggested question 1, 3, 5, 7, chapter 3, question 3, question 5, okay? So for chapter 4, 5, 7, 8, 9, all those chapters, you do, double second. Oh, okay, okay, I missed questions for those chapters. It should be, let me double check, chapter 4. Chapter 5. I need to update those question lists because it means to questions 1 to 8. Okay, so questions 1 to 8 for chapter 4, 5, 7, 8, and 9. Question 1 to 8. Okay?
Okay.
Yeah, question 1 to 8 for chapter 4, 5, 7, 8, and 9. Thank you for bringing that up. Okay.
Yeah, and is these questions, were they just for last week, or is this for like throughout the semester?
The whole semester.
Oh, okay, that makes a lot of sense because I was trying to do them all at once, but it seems like a
Yeah.
lot.
So those questions are for whole semesters. Okay.
Okay, perfect.
All
Thank you so
right.
much.
Thank you. Another question: do we have weekly modules? We do not have weekly modules. Instead, we have weekly learning activities. Okay. So, for example, course outline. If you go to the course outline under the content, okay, so this is the Word document. So we follow weekly schedule. So last week was week 1. We did chapter 1 and chapter 2, okay? So this week we'll start review what we did last week, chapter 2. And then, actually my schedule is a little bit different from posted here. I'm a little bit faster than we scheduled here. So today I'm going to talk about chapter 3 actually, but I will start with chapter 2, review chapter 2, then start of chapter 3, go most content for chapter 3. Okay, so anyway, this you can use as a reference, okay, as the reference. And our test 1 is March 1st, etc. So we follow this schedule roughly, not exactly. So our lecture, live lecture is a little bit faster. The reason is that we have room to catch up, to, you know, do more questions on some important concepts, okay? All right, so any other questions? Any other questions? The PowerPoint in that, let me try to resend the chance. Do we have weekly modules? Have anyone has the WhatsApp? I don't know if you have, please share. And only use WhatsApp for good reason. In the past, we caught students using WhatsApp for cheating, okay? Everyone involved get punished, okay? So any other questions? Yeah, selected question for whole semester, okay? Any other questions? All right, so the PowerPoint slide is posted under the lecture slides. Sometimes I need to do some work on Excel or SPSS. I will try to post those under lecture notes, class notes, okay, class notes. All right, so this is week 2. Week 2. We are going to.
Quick question.
Yes, please.
Do we have to use SPSS, or can we also use R instead?
Yes, you can use SPSS, or you can use R, or you can use SAS, or you can use Minitab. But SPSS is the software introduced in class. If you need to use other software, you're responsible for the techniques by yourself. In class, we just cover SPSS. You can use any software.
Thank you.
You're welcome. Okay. Any other questions? Okay, thank you for your question. So I will do a question from, so we start with review of basic statistics, chapter 2. Okay, so the questions is posted here. Okay, if you have textbook, you can open it. I'm going to just close my door to reduce some noise. So it is toward the end of chapter 2, page 47. Page 47, question 3. Okay, question 3. So this question is give you the data. Okay. So those are the original data. There are 30 of them. So sample size n equal to 30. So question A asks you the estimate of mean percent earnings for the population. So to estimate the mean for population, that is the question. Given sample data, how do you estimate the mean for population? Any idea? Those are the sample data. Those are the sample. Remember, inferential statistics is draw conclusion about the population based on sample data. When sample data is given, your question is to estimate the mean for population. So how do you approach to this question? This estimate is actually a point estimate. What is the best point estimate for population? The answer is sample mean. Use sample mean to estimate population mean. Okay, so how do you do the sample mean? You add all those 30 numbers together. Okay, add all the number together, divided by 30. Add all the number divided by 30. And you are going to get sample mean, 10.69. The unit is a percent. Okay, any questions? Use sample mean to estimate population mean. So we finished question A. Question B, construct a 95% confidence interval for the mean percentage earnings for population. So construct 95% confidence interval given large sample argument. Suppose those 30 data is a large sample. So when you consider a sample as a large sample, you use normal distribution. If it is large sample, you use normal distribution. Okay, this means normal distribution. And the question asks you the interval, so you use normal distribution formula. So question B, the formula is X bar plus minus Z half alpha times sample standard deviation over square root of sample size. So Z half alpha is a critical value. S is sample standard deviation and sample size. Okay. And we already know X bar from question A is 10.69. And now we need to figure out when you have 95%, what is the Z half alpha? What is the critical value? Remember last class, we talked about when you have this 95%, means this is central area, 95%. This point is Z half alpha. How do you find that point? Yes.
I think the mean is 10.76.
You are correct. My mistake. Thank you so much. 10.76. Thank you so much.
No problem.
Yeah, 10.76. Okay, my typo. Okay, so 10.76. Okay, any other questions? Okay, now we have this 95%. How do I find this Z half alpha? You can find it in the calculator, okay? Now I'm going to open Excel. Just to try to adjust the window. Okay, so I'm going to use this cell. This is so you can use a normal distribution. Okay. In Excel, you can type in norm dot INV. Okay, and the probability, you type in 0.975, mean is 0, standard deviation is 1, and you get 1.96. Okay, 1.96. So you get that 1.96. And why I use 97.5% or 0.975, because Excel calculation is based on area to the left. When you have 95% in the middle, the area to the left of this Z half alpha is 97.5%. This area, 97.5%. Okay, so we found that the critical value 1.96 times standard deviation of original data. What is the standard deviation original data? It is 13 point standard deviation, 13.71. Make sure you know how to get this number. In textbook, make sure you know how to get standard deviation. If not, ask me separately, okay? So go back to here, you plug in the standard deviation times 13.71 over square root of 30, okay? And you can get lower bound, upper bound. Okay. So lower bound 5.85, upper bound 15.67. The unit is percentage. Okay. Any questions for question B? When you have large sample, it is normal distribution, found the critical value. Okay.
Hi, Professor. I have a question here.
Sure.
So for like the Excel, when we calculate the standard deviation, are we gonna use like in Excel is the stdev.s, and then we gonna put all the numbers together to calculate it?
So when you use Excel to calculate standard deviation, it is stdev. Your question is, do I use .p or do I use .s?
Yeah.
Is that your question? Thank you. When you calculate sample standard deviation, you use .s, means sample. When you calculate population standard deviation, you use .p.
Okay.
So for this example, you use .s.
DEV is not.
Yeah, stdev. Yeah, thank you. Yeah, stdev.
Okay.
.s. Okay. Any formula in Excel start with equal. Okay.
Okay.
Okay, thank you. You're welcome. So make sure you know how to do the standard deviation in Excel. Okay. So that is the formula. Okay, question C. Construct 95% confidence interval for the population mean if it is a small sample size, if 30 is a small sample size. If 30 is a small sample size, you use a T distribution, student distribution. You use student distribution, okay? When you use student distribution, the formula becomes X bar plus minus T half alpha times sample standard deviation S over square root of sample size N. Okay, over sample size N. Again, and how do you use SPS as Excel to figure out the critical value for T half alpha? Okay, so to use Excel, you type in equal T dot INV dot, it is two-tailed test. Okay, you use the alpha, so 0.05, then degree of freedom. Why it is 0.05? Because in T distribution, you use the area for left tail area plus right tail area. That number as a probability. Okay, so 0.05, degree of freedom, sample size -1, 30 minus 129. Okay, so you get this 2.04. Okay. .045. So that is the critical value for T. And then you plug in X bar 10.76 plus minus 2.045 times sample standard deviation 13.71 over square root of 30. And final answer you get 5.64 to 15.88. The unit is a percentage. Any questions? Any questions? Okay, last question, question D. Compare the result from part B and C. Why sample size 30 is often taken as the cutoff between large and small samples. You may recall when you studied CQMS703, people are talking about when sample size greater than 30, it is a large sample. When sample size smaller than 30, it is a small sample. Why is that? Why 30 is the cutoff? So from result of B to C, you can see the critical value for normal distribution is 1.96. The critical value for T is 2.045. They are very close in absolute value. Okay, so that is the reason 30 is used as cutoff. Any other questions?
Sorry, can you repeat why it's a cutoff?
Because when sample size equal to 30, when you consider two situations, one, normal distribution, two, student distribution, those two situations produce similar critical value. The critical value are very similar. So 1.96, similar to 2.045, are very close to each other. Okay. All right, any other questions? Okay. So that concludes chapter 2. Chapter 2, we go over this exercise. Other questions in chapter 2 have similar calculations, okay? Make sure you redo this question, understand how did you get 1.96, how did you get 2.045, and how do you apply confidence interval estimate formula. All right, so today we'll go over chapter 3. Chapter 3 is exploring data patterns and the introduction to forecasting techniques. If we take a look at this graph, okay, this graph is showing a data pattern over maybe past 20 years. Okay, let's say it is sales data. Okay, it is maybe house cost. It is the cost of housing over 20 years. And this is time series data. Okay, as every year goes by, the trend is to goes up, but some years the price is going down. You see here, the price is down, but overall price goes up. Okay, and we call those points are cyclical peak, and these points are cyclical valley. Okay, so this is an example of time series data. This data shows the trend component. If you have data going up or going down, that is the trend. Use trend. Okay. And you have the upside down, up, down, up, down, up, down. Okay. Those are cyclical components. Okay. So this is just give you a visual representation. What is time series data looks like, and what could be the characteristics. When you analyze time series data, an important concept is autocorrelation. Okay. What is autocorrelation? I will use this data as an example. So this data is a sales data for VCR. Okay, it is a sales data for VCR. It is for 12 months from January to December. So those are the original data. In January, you have 123, February 130, etc. Okay, so those data we use YT. YT means this data at time T. Now I will introduce YT minus 1. YT minus 1 represent lagged one period. Lagged one period. What is lagged one period? You move this number 123 down. When you move down one position, it comes to here. It becomes here. Okay, and then when you move this 130 down one position, it comes to here. Okay, and then you get this one lagged one period. Lagged one period. We use Y subscript T minus 1. Okay, so now you have original data YT. You have Y lagged one period. Any questions for those two concepts? Original data and lagged one period. Any questions?
Professor, why
Yes.
do we need to move it one down for the lag 1 and the lag 2? What's the reason by doing that?
Good question. The question was why we need lagged 1 or lagged 2? Why we need to move 1 down? This is because these data are time series data. So this is for January, this is for February, no problem. The reason we move 1 down is we want to explore the trend. If data, we want to investigate the characteristics of the original data because we found the data are connected. For example, don't you think 130 is a greater than 123, right? So looks like these data are going up. You see, oh, of course, this one is going down, but the general trend is going up. Okay, general trend is data going up. So we want to explore the original data, the relationship between original data with like the one period, this data with this data. We want to introduce a concept, autocorrelation. Why we need like the one period? We need to explore the original data and like the one period data. Why we need those two sets of data instead of just one? Because this is time series data. It is the later, those data are connected with each other. We want to see the connections, the relationship, the correlation. We need to see the correlation. Okay. Hope that answered the question why we need lagged time, because we want to build forecasting model for this data. We want to do analysis for this data, original data. The lagged one period is just additional tool, additional data we want to explore. The purpose to set up a forecasting model for original data. This is our target. In order to do this, we need to move data one period down to produce lagged one period, because we believe in time series data, the data in the later time connected to data in previous time period. This is our belief in time series data. Okay, if in other situation, for example, your student, the student final mark, in this class, I have 65 students. So I should have 65 data, your final mark. Those final mark, look at each student mark it is not a time series, it is just cross section. So by the end of April, I have to give you a final mark on the grid portal. That is a cut point. At that point, every student have this mark. Okay, this is not time series data, your final mark. It is just one at that point, your final mark. Okay, for time series data, we believe the data in later period have connection with the previous data. Okay. Any other questions? Why we need this one-time lagged one period? Okay. So after we use, this is lagged one, we can have lagged two period. When you have lagged two period, move the first number down to position here. The first number becomes here. Okay. So that is the lagged two period. And we have lagged three period. So lagged three, 123 would be here. 130 would be here. This is lagged three, etc. Okay. Actually, another reason why we need to use lagged one, we want to use a naive model to predict. So if you want to predict what is the sales for February, how do you predict February data? There are many methods. One method is called naive. You use last month's data to produce February's data. So you use January to forecast February. And then you use February 130 to forecast March. You use March 125 to forecast April data. Okay, so we want to use forecast, make forecast. This is another reason why we need use the lagged one period. Okay, so now introduce a autocorrelation coefficient. What is autocorrelation coefficient? it is just a formula. This formula a little bit complicated because the reason is it is used like K, like the K. It didn't say like the one, like the one. It didn't say like the two, like the three. It is like the K because this is mathematics. This is statistics. We want to draw formula. Okay, we want to apply to general situation. This K could be 1 means like the 1. K could be 2 means like the 2. K could be 3, etc., etc. Okay, so if you want to calculate the K autocorrelation coefficient, this is the formula, 3.1. Okay, this formula said, use Y bar. Y bar is the average original data. The average of original data, that is Y bar. Okay. And then this number YT. YT is original data, see? Okay. And Y bar is the average of all the original data. Okay. And here you have T minus K. YT minus K means like K. When K equal to 1, you get, when K equal to 1, you get Y subscript T minus 1. When K equal to 2, you get Y subscript T minus 2. So hope you know the notation of Y T minus K. Okay, and then you do multiplication. After you do multiplication, you add them together. This sigma means add them together. That is how you calculate K, autocorrelation coefficient RK. Okay, K actually can go through the 0, but we seldom use 0. We usually use K from 1, 2. Okay, so now let's look, any questions on the formula? Okay, now I'm going to calculate R1. How do I calculate R1? Based on this formula, calculate R1. Okay, so first, let's write down the formula for R1 based on this general formula. Okay, so to write down the formula, you just R1, substitute K equal to 1, so it becomes sigma T from 2 to N, and then YT minus Y bar times YT minus 1 minus Y bar over sigma T from 1 to N, and then YT minus Y bar square. Okay, so now we need to know what is the average of this number. So Y bar is the average. Okay, so what is the average of all these numbers? You add all these numbers together, divided by 12, okay, and you got 142. The average is 142. Okay, after you got the average of those numbers, and then you expand this formula. Okay, so I'll show you the original number. So YT, when T equal to 2, when T equal to 2, what is Y2? Anyone? When T equal to 2, what is YT?
130.
Excellent, 130. So this 123 is Y1, 130 is Y2, Y3, etc. Okay, so it is 130 minus Y bar is 142. times yt minus 1 when t equal to 2. It is yt minus 1 becomes 2 minus 1. So this yt minus 1 becomes y1. So what is y1? Anyone, what is y1? I'm going to this item. Anyone, what is yt minus 1 when t equal to 2? That is the question. Thank you, Matthew. 123. Thank you so much. Y1, see here, I type Y1 123 minus this Y hat, Y bar is 142. Okay. This sigma means times plus next one. Next one, t equal to 3. Next one, t equal to 3. So maybe I need to use more space. Okay, here I'm going to, yeah, I have space here. Next one, t equal to 3. When t equal to 3, what is yt? This is y3. See, y3 is 125 minus y bar 142 times. Next is yt minus 1. When t equal to 3, this is y2. Y2 is 130 minus y bar. Y bar is 142. You keep on going. Keep on going. Okay. So that is something on the top. On the bottom, it is a yt minus y bar squared and add them together. So on the bottom, you have 123 minus 142 squared plus next y is y2. 130 minus 142 squared plus until, keep on going, until last one, 160 minus 142 squared. Okay, and the final result, you get 0.463. That is R1, not this one. So R1 is, no, it is 0.572. This 572. So any questions to calculate R1 autocorrelation? At one time lagged one time.
Sorry, I wasn't paying attention. How did you get 142 again?
Thank you so much. 142 is the average of original data. Add all this data together, divided by 12, you got 142. Average.
Great, thank you.
You're welcome. Thank you for asking. Average of original data is Y bar. Okay. Can you do example using the formula? This is the example I'm using formula. Or can you specify what your question? Oh, okay, that was previous question. Any questions? Thank you, Matthew. Any questions? When you do the specific calculation, I would suggest you use Excel to organize the data. Okay, you can use Excel to organize data in this format. This is the, if you use Excel, you type in the original data, you can calculate the average. Okay, then you list lagged one period, yt minus 1, and you calculate yt minus y bar, yt minus 1 minus y bar. Okay, you follow this format, you can do the calculation. Any questions?
And is there a way to, you can organize it in Excel? Is there an Excel formula that will do the formula for you?
There is not direct formula in Excel, but there is a SPSS directly give you the result. Okay, so this is the one I'm going to turn to using SPSS. So this is the original data I have here. Okay, I'm going to delete all the other data here. Oops. So this is my YT original data. And then if you copy this data in SPSS, you will get the autocorrelation. This is the procedure I'm going to show you, okay? So I just select this data, right click my mouse, quick copy, and then I open the SPSS. I already have pasted here. So this is my SPSS data. Actually, I just copy and paste. That's it. I changed the variable name, except this one has 2 decimal, but I can easily eliminate this 2 decimal to no decimal. So go down. Okay, so now it is a SPSS. Okay, you can copy and paste from Excel to SPSS. Once you have here, just try to okay. So you go to analyze, go to forecasting, and then select autocorrelation. Autocorrelation. After that, you select variable. Initially, it is this format. So you select this YT into variable. And then you click OK button. So you have this output from SPSS and give you the autocorrelation. I will copy this to OneNote because this part is important. I'll just copy the screen maybe. So this is the output from SPSS. This is your R1. We just calculated by hand, 0.572. You can also calculate R2. Okay, it is 0.463. So use this method, you can directly get autocorrelation. Okay, any questions? How do you get autocorrelation? For Excel, student asked, can I use Excel? Excel, you can follow this format to do manual calculation. This is Excel format, you can do it, okay? And our textbook toward the end of chapter 3, also use some sum product, use some functions to calculate the autocorrelation. I would not suggest using the textbook Excel method. I would suggest either use SPSS or R or SAS, Minitab, etc., or use Excel to do manual calculation. Okay, I would not suggest using Excel formula because it is involved in sum product offset. Okay. So go back to autocorrelation.
Professor, I have a question here.
Yes.
Do we have a link to download the SPSS?
Thank you. This is the link. You do not download. You use SPSS remotely. Okay, you can access SPSS remotely from your computer, you just need to go to this link, or you Google Ryerson Virtual Lab. You will have this link, and then you log in with your Ryerson credential. So if I Google, if you don't remember the link, you Google Ryerson Virtual Lab, Ryerson Virtual Lab, you have this link, virtual applications. Under this link, you click this one here, vapps.ryerson.ca. And you need to log in with your My Ryerson credential and Microsoft multi-factor authentication. If you do not have MFA, you have to set it up. And if you have questions about remotely access SPSS, you have to contact CCS help desk. Okay, so help desk to solve this problem. I have no resources and authorities to set you up to access SPSS. Any question for SPSS, you go to here. There is a contact us, some contact us, go to here to have your questions answered, okay? Contact us. Other questions? And the other way, you have every student have 1 month free installation from IBM Microsoft. So you just, again, Google IBM SPSS free trial. IBM SPSS free trial. Then go to IBM SPSS trials. So you can download. It is free for 1 month. It has latest version 28. Free for 1 month for one computer. After 1 month, if you change computer, if you have 2 computers, you repeat yourself, use another computer, but you cannot use the same computer to do second trial. Okay. All right. So any questions about remotely access SPSS or use 1 month free trial version? All right. Shall I propose we all take a 10 minutes break? After break, we continue. Okay. I'm going to stop recording. Then when we come back, I will continue recording. Did I record? Stop recording.